So in this question, a mass of 4 kg rests on a horizontal plane. The plane is gradually inclined to an angle of 15 degree so that it just begins to slide down. Okay, so we need to find a coefficient of static friction, right? Suppose this is the inclined plane, so it is inclined at an angle with the horizontal. Suppose this is 15 degree, such that the object of 4 kg, mass 4 kg, just starts to slide down. So that means this angle must be angle of repose, and the relation between the angle of repose and static friction, coefficient of static friction mu s, is given by tan theta, where theta is angle of repose. And in this problem, theta is equal to 15 degree. So here coefficient of static friction will be tan 15 degree. So now we are to apply here tan A minus B formula, because 15 can be written as 45 degree minus 30 degree. Okay, so what was the formula? Tan A minus B. So hope you know that tan A minus B formula. Tan A minus B is equal to tan A minus tan B by 1 plus tan A tan B, right? This is the formula. Here angle A is 45 and B is 30 degree. So if we use that formula, then what we're gonna have? So now you see, then tan 45 minus tan 30 divided by 1 plus tan 45 into tan 30. That's what we're gonna have, right? Tan 45 into tan 30. That's what we're gonna have. So now tan 45 is 1, tan 30 is 1 by root 3, right? And 1 plus tan 45 is again 1, tan 30 is 1 by root 3. So what we have got, 1 minus 1 by root 3, 1 plus 1 by root 3. So if we multiply both the numerator and denominator, or if we take LCM root 3, then we're gonna have root 3 minus 1 by root 3 plus 1. Root 3 will be cancelled here. So now if we simplify this, just give me a second. So if we simplify this, let me rationalize the denominator, root 3 plus 1. So let's multiply root 3 minus 1 here, and if we multiply root 3 minus 1 with the denominator, then it must be multiplied with the numerator as well. Root 3 minus 1 into root 3 minus 1, that means root 3 minus 1 whole square. So root 3 square is 3 minus 1 square is 1, and root 3 minus 1 whole square, that's going to be 3, 2 root 3 plus 1. Okay, so 4 minus 2 root 3 divided by 2, so that means 2 minus root 3. So 2 minus root 3 is the coefficient of static friction here. 2 minus root 3 is approximately equal to 1.73. Okay, if we subtract these two, then what we're gonna have? We're gonna have 0.27. So this is the answer, this is the required answer, coefficient of static friction. Okay, so this is our next question. Discuss the motion of a car on level road or on bank road. Okay, that means we need to discuss any one, but I'm going to show you both. Okay, find expression for V max, that means maximum speed, on that path. So first let us discuss about motion of car on a level road. Okay, now let us consider a car on this level road which is curved. Okay, this is the car, suppose. Okay, now we know when an object is moving in a circular path, okay, when something in uniform circular motion, then what happens? When object is moving in a circular path, then a force which is called centripetal force that acts towards the center of the circular path, and this force keeps moving this object in the circular path, right? So here you see this car, when it will take turn, okay, the centripetal force towards the center on this car will be provided by the friction between the tires and the surface of the road. Okay, so that means you can consider this way. Suppose this is a rope and you have tied something here, a stone or any other solid material, and you are whirling a stone. Okay, you tied up this with this rope, and along this rope there will be centripetal force. This rope will provide the centripetal force which keeps this stone moving in this circular path. But in this case, when this car takes the turn on this curved road, the role of this rope will be played by the friction between the tires and the surface of the road. Okay, so now you see, and that centripetal force Fc is equal to mv square by r, if r is the radius of this curve, and then here it will be capital. Okay, and m is the mass of the car. Okay, now if you see, so this is the centripetal force, and now you see, if the speed increases, then this force, centripetal force, also increases. Okay, but the friction between the tires and the surface has a limit. Okay, beyond which it cannot provide that centripetal force. Now if you keep increasing the speed of the car, then if this centripetal force cross the static friction between the tires, maximum static friction, that means the limiting friction between the tires and the tires and the surface of the road. Okay, then this car will move away. It cannot stay on this circular track. It gonna skid away from this skid of this track. Okay, this car will skid off this track, right? So this centripetal force mv square r, if v is the maximum speed, okay, up to which this car will be on this road, then this must be equal to the maximum limit of this force is equal to the static friction, limiting friction, sorry, not static friction, limiting friction. Okay, right? So that is written as Fs max. Okay, right? So now let me write what I have considered here. So here we have considered a car of mass m moving with speed v on a curved level road, okay, of radius r. Then centripetal force is, let me write here, Fc is equal to mv square by r. Okay, which is provided by the friction between tires and road. Okay, so that let me write that friction Fs. Okay, so that means Fs is the static friction here. Now you might think that why I am writing here static friction, though the car is moving, because the car is moving along this road, okay, but not in this direction of the centripetal force. So that's why I am using here static friction, and this static friction doesn't allow to skid off doesn't allow the car to skid off the road. Okay, so hope you have understood this. Now you see, for maximum speed okay. V max, this centripetal force m v max square by r, that will be equal to the limiting friction Fs, where Fs max is the limiting friction. So here you see, let me clean these things, just give me. Now let me simplify this. We know that this static friction is equal to coefficient of static friction, that is mu s, into n, which is the normal reaction force, which is acting upward, okay, which is acting upward on the car, okay. So now you see, this is the road and this is the car. Then if the mass of the car is m, then mg is acting downward, then the normal reaction force is capital N, which is equal to mg, right, but opposite in direction, that is mg, sorry, not mg. So that's why we can write mu s m into g, okay, where mu s is the coefficient of static friction, right. So now let me copy the last step and let me go to a new slide. So this is what we have got, okay. So let me write it properly, just give me a second. So from this step, what we have got, m v max square by r is equal to mu s m into g, here m cancels, so that's going to be equal to v max square equal to mu s r into g. So that's why v max is equal to root over mu s r into g, right. So this is the required expression. Hope you have understood this. Now what if the outer edge of this curved road is raised, okay, if one side, this outer side is raised, okay. So that means we are going to discuss about the bank road. So what is bank road? Now you see, let me insert a picture here. So here you can, now here you see this outer edge of this curved road. This is a curved road. This outer edge is raised up, okay. In this case, the direction of the centripetal force will be in this direction towards the center, and the frictional force will be in this direction, okay, because the frictional force is always tangential to the surface where two surfaces contact, okay, two surfaces are in contact, okay. So now you see, this centripetal force will be provided by one component of the normal, one component of this normal, okay, and one component of Fs, okay. So now if you resolve into components, now here you see this angle is theta, here you can see if this angle is theta, then this angle will be also theta, right. So now you see, first let us resolve this normal force into components, okay. So here you see this component that makes angle theta with the normal, that will be n cos theta, and this component will be n sin theta. Hope you have the idea of the vector resolution, okay. Then this Fs can be resolved into, so if this angle is theta, then this angle must be also theta, here you see. So let me write this Fs here. So this is nothing but the direction of Fs, this is parallel to this, okay. So this centripetal force, direction of centripetal force here, it will make angle theta with the direction of the frictional force, okay. Because here you can see clearly, if this is theta, definitely this will be also theta. Let me show you something. So here you see, if you draw a parallel line here, if you draw a parallel line here, you can see which is parallel to this line. These two lines are parallel, and now you see if this angle is theta, as this base is also parallel to this line, so now this angle and this angle, these two are alternate interior angles, this must be also theta. That means this direction makes theta angle with this Fs, right? Hope you have understood this. Now let me clean this, just give me a second. Okay, now here you see, so component of Fs in this direction is Fs cos theta, Fs cos theta, right? Because here this direction of Fs is here is also theta, right? So hope you have understood this. And there will be another component of Fs in this direction, okay, that is Fs cos, sorry, not cos, sin theta, Fs sin theta, right? So again, let us consider the mass of the car is m, and the radius of the road, curved road is r, and the speed of the car is v. Okay, let me write here. So here I have considered a car of mass m is moving on a curved bank road of radius r with speed v. In that case, you can see this direction, these two forces Fs cos theta and n sin theta will provide the centripetal force. So we can write mv square by r is equal to Fs cos theta plus n sin theta. This is one equation number 1, and another is, now you see this mg plus Fs sin theta, that gonna be equal to ns cos theta. So here we can write that n cos theta, that will be equal to Fs sin theta plus mg, because this car is not moving upward or downward, so that's why these two must be equal. Okay, the upward and downward forces must be equal, right? Hope you have understood this. From here, let us simplify this to get mg. Mg will be equal to n cos theta minus Fs sin theta, Fs sin theta. Okay, so this is equation number 2. Now let us divide equation number 1 by 2. Okay, let me copy these two equations 1 and 2, and let me write on the other side. Okay, here is the new slide. Okay, now let us divide equation 1 and 2. Equation number 1 divided by equation number 2. If we divide that, then what we're going to have, mv square by r divided by mg is equal to Fs cos theta plus n sin theta by n cos theta minus Fs sin theta, right? So here you see m gone, so we're gonna end up getting v square rz is equal to, now let us divide both the numerator and denominator by n cos theta. Then what you're gonna have, then you're gonna have Fs by n. If you divide both the numerator and denominator by n cos theta, both the numerator and denominator, divide it by n cos theta, then what you can have, if you divide this term by this, then you're gonna have Fs by n, as this cos theta and cos theta cancels, and plus n sin theta by n cos theta, that's gonna be, tan theta, because n cancels, sin theta by cos theta is tan theta, right? Divided by, again, this n cos theta by n cos theta, that's gonna be equal to 1 minus Fs sin theta by n cos theta, that's gonna be Fs by n tan theta. That's what we have got, right? So pause the video and note it, and let me copy the last step, and let me take a new slide. And you see, for maximum speed Vmax, this is gonna be equal to the coefficient of static friction. So So in this case, this expression will be written this way. Let me write here. Okay. So for V max, so here we're gonna write V max square. Okay. For V max square. So here in this case we're gonna write Fs max. Okay. Fs max. Right. And here also we're gonna write the limiting friction Fs max. Right. Hope you have understood this. Okay. So in that case, here we can put that, you know, that Fs max is equal to the coefficient of static friction into n. So that's why we can replace this ratio by coefficient of static friction, right? Hope you have understood this. So here we can write, therefore this can be written as V max square by Rg is equal to mu s plus tan theta by 1 minus mu s tan theta, right? Since this is equal to this, right? Hope you have understood this. So therefore V max square will be equal to Rg into, let me write the right hand side here, into this. And so if you remove this square, then what you're gonna have? You're gonna get this expression, right? So that's the answer. Hope you have understood this. Now let us take the next question. So here is the next question. An object is on an inclined plane. This is an inclined plane, suppose, and here we have an object. Okay. Now the angle made by this inclined plane with the horizontal is theta max, such that this object starts to slides down. Suppose this was the initial angle of inclination. This is suppose theta 1. Now it is increased to theta 2. Suppose now it is increased to theta 3 gradually, such that the maximum angle when this object starts to slides down, that is angle of repose. So angle, you know, if the angle of inclination, when the angle of inclination was less than theta max, then it was at rest. When the angle becomes suppose theta max, then it just starts to slides down. That means this is angle of repose. That was the definition of angle of repose, right? So now you see here, just let me redraw this diagram. So here is the object, and this is theta max. Okay, this is theta max, right? And the normal reaction force will be in this direction, perpendicular to this surface, right? This is normal reaction force, and as it slides down, so the force of friction will be acting in opposite direction, Fs. Here I am going to write Fs max, because in this situation the friction will be the limiting friction when the object just starts to slide down. Okay, now you see the mg, m into g, mass of the object, g is the acceleration due to gravity, will act in this direction, downward direction, right? Now here you see, let me increase this, let me produce this in this direction. Now here you see, this is also mg. If this is theta max, this must be also theta max, right? This angle must be also theta max. This is theta max, right? Then this is mg cos theta max, right? This is mg cos theta max. And now you see, in this case here, this magnitude of this friction force will be equal to this mg sin theta max, right? So now you see, hope you have the idea of vector resolution. So this mg is resolved into two components. One is mg cos theta max, another is mg sin theta max. So this is equal and opposite to this fs max. So now you see here what we can do. This, let me consider, let m be the mass of the object on the inclined plane. Theta max is the angle of repose. Right? Theta max is the angle of repose. Let me write it properly. Theta max. And to prove, here we are to prove that theta max is equal to tan inverse of mu, where mu is the coefficient of static friction. Right. Now pause the video and note this, because I'm gonna clean these things. Okay, pause the video and note this. So now you see, let me clean this first. Hope you have noted this. Now you see, this fs max, that must be equal to mg sin theta max, and this normal here, you can say this normal, and this is equal and opposite to mg cos theta max. So we can write n is equal to mg cos theta max, right? So their magnitudes are equal. So now if we divide this one by this, if we divide, this is equation number 1, suppose this is equation number 2. Dividing equation number 1 by equation number 2, what we're gonna have? We're gonna have fs max by n is equal to mg sin theta max by mg cos theta max. So here mg gone, mg gone. So here you see sin theta max by cos theta max, that's gonna be tan theta max, right? Tan theta max. So now you see, this is nothing but mu, right? So now you see, let me clean this diagram. Okay, hope you have drawn this diagram. Sorry. So now you see, let me clean this first. Pause the video and draw this diagram. Now you see what we can do. We know that fs max is equal to mu into n. N is the normal reaction force. So therefore, here you see fs max is divided by n is equal to mu, right? So now you see, you can replace this term by this tan theta max, because this is equal to tan theta max, right? If you do so, then what you're gonna have, then you see, let me just give me a second. Okay, then what you can do now, let me write, this is equation number 3. So using 3 here, we can write mu is equal to, tan theta max is equal to tan theta max is equal to mu. Okay, using equation number 3, right? So now you see, from this relation what we can write, if tan theta max is equal to mu, then we can say that theta max must be equal to tan inverse of mu. That is what we need to prove, right? Hope you have understood this. So now what is the next question? Let me take the next question. Here you see, it is well known to us that Newton's second law of motion is stated mathematically as given below, that is F is equal to kma, where value of k is 1, we know that, right? So here we need to define k, and also we need to define 1 Newton force, right? Now let me write the answers. This question was also asked in 2023, right? So let me write this answer here. In the formula, F is equal to k ma. K is nothing but, it is a constant of proportionality. It is a constant of proportionality. Right? Such that its value is, okay, its value is 1 in SI unit system, right? Okay. And definition of 1 Newton, 1 Newton, 1 Newton is defined as, or you can write 1 Newton is the force that produces an acceleration of 1 meter per second square in a body of 1 kg mass, right? So this is the definition of 1 Newton, and this is the definition of K. This is definition of 1 Newton, right? So now let me take the next question. So here is the next question. This was also asked in 2023, right? And here, Aristotelian law of motion may be stated as, an external force is required to keep a body in motion. Explain whether there is a any flow in this law. So now you see, suppose an object, this is on a frictionless surface, suppose this is on a frictionless surface, then you see, if it moves with if it is moving with a constant velocity, right? Okay, just if you pushed it once, and once it started moving, then suppose moving with constant velocity, then you are not applying any force, but it is moving with constant velocity. If the velocity is constant, that means there is no acceleration. Acceleration is 0. If acceleration is 0, according to this formula F equal to ma, that's going to be equal to 0. Force going to be equal to 0. So without any external force, a body which is already in motion, that will continue its motion without any external force, right? That is the flaw here. So let me write the answer. So when you will write the answer, first write the statement of this law, okay? Write the statement first. I'm not going to write this statement as already in the question. So first do write the statement, then you write the region. Then you write the flaw. This law doesn't. One more thing. First you mention this. First you mention this. Yes, there is a flaw in this statement. Okay. In this law. Okay. So what was the flaw that this law doesn't account for friction or resistance that opposes the motion, right? So this was corrected by Galileo later on. Okay, here you can add one more thing. Let me just give me a second. Right here you can add one more thing, that is that if a body is moving on a perfectly frictionless surface, okay, no external force is needed to keep it moving, right? So hope you have understood this. So now let me take the next question. So if the external force on a body is 0, then which of the following is 0? So external force is 0, F is equal to ma. If it is equal to 0, mass cannot be equal to 0, right? So that's why only acceleration can be 0 here. So option D is the correct option, right? This question was asked in 2025. Next, a constant retarding force of 50 Newton is applied to a body of mass 20 kg moving initially with a speed of 50 meter per second. Initially it was moving with 50 meter per second. Okay, then a retarding force is applied. F is equal to 50 Newton. Okay, and mass of the body is 20 kg. Okay, how much time does the body take to stop? Okay, so first let me write here minus, because it is retarding force, and we know F equal to ma. So let's find the acceleration first. So acceleration will be equal to minus 50 by m is 20 kg here, m is 20 kg. Okay, acceleration, so it should be meter per second square. So that's getting minus 2.25 meter per second square, right? So now you see, let us find the time. Okay, how long will it take to stop? We know that v is equal to u plus a t. Now here we are to obtain the time when it will stop. So final velocity should be taken as 0, v should be taken as 0. So 0, u is 15 meter per second. Acceleration we have got minus 2.5. T is the unknown quantity that we need to find, t, that is time. So here we're going to get minus 15 is equal to minus 2.5 into t. So t will be equal to minus 15 divided by minus 2.5, minus gone. So here 150 divided by 25, that means 6 times, right? 6 times, 6 seconds. Okay, so it will take 6 seconds to stop the body, right? So here is the answer. So next question is, define coefficient of friction mu, and if the coefficient of friction is 1 by root 3, then find the angle of friction between the two bodies in contact, right? So what is the definition? So we know that friction is equal to coefficient of friction into n. So which means coefficient of friction is the ratio of friction and normal, right? So So that's why we can write the definition this way, that the coefficient of friction, and also one more thing, this is also force, this is also force, so it must be dimensionless. Okay, the coefficient of friction mu is a dimensionless quantity, scalar value, quantity or scalar value, okay, scalar value, which is the ratio of frictional force and frictional force to the normal force, right? So this ratio is coefficient of friction, and if the coefficient of friction is 1 by root 3, that means we know that the coefficient of friction is also given by tan of angle of friction, that is, let me take that is theta, and 1 by root 3. We know that tan 30 is 1 by root 3, so here angle of friction must be 30 degree. Okay, so this is the angle of friction, right? So now let's move on to next question. So state and prove Newton's second law of motion. Discuss some important points about the second law, right? So first let me write the statement of Newton's second law. So Newton's second law of motion states that the time rate of change of linear momentum of a body is directly proportional to the net applied force on the body, and this change takes place in the direction of the applied force. So what does it mean actually? Suppose this is an object, it is moving with velocity u, then suppose its mass is m, and if you apply a force F, and as a result its velocity increases from u to v. Suppose its velocity increases from u to v due to application of this force, then change in momentum. What is the change in momentum? Here you see initial velocity is u, so that's why initial momentum is pi is equal to m into u, and final momentum pf is m into v, right? And the rate of change of momentum, suppose time taken is t, suppose to to change the velocity from u to v, t time is taken, suppose, then the rate of change of momentum will be given by pf minus pi by t, and this rate of change is directly proportional to the applied force. Okay, and this changes takes place in the direction of force. So what does it mean? That means now you see, if this is moving in this direction and if you have applied the force in this direction, then velocity will be increased, right? Okay, so this direction is taken, suppose positive. Okay, velocity is increased. Okay, so the change in momentum will be also positive. Change in momentum will be positive, right? Now you see, suppose this object is moving in this direction, and if you have applied force in its opposite direction, so in negative direction, now here you're gonna have change in momentum negative, because you see suppose it is moving with 5 meters per second, and if you apply the force in opposite direction, then its velocity will be reduced, right? Suppose it becomes 3 meters per second, then here you see, if this is 1 kg, then final initial momentum is here, pi is here 1 into 5, that is 5 kg meter per second, second, and final momentum is here 3 into 1, that is 3 kg meter per second, right? So now here you see, if you find Pf minus Pi, here you're gonna have minus 2, right? So it is taking place in negative direction, right? So hope you have understood this. Now you see, now let me clean this statement and let me prove this law. Okay, just pause the video and note this statement. Now let me show you how to prove this. First let me clean these things. Okay, so hope you have noted all these things what I have written here. So here you see, let P is the linear momentum of a body, linear momentum of a body, right? And F be the net applied force on the body. Okay, now change in momentum in the time interval dt. Okay, here you can see, let me write like this: if del P is a change in momentum in time interval del t, then the rate of change in momentum, change of linear momentum will be given by del P by del T, right? Del P by del T. Okay, now if del T is very small interval of time, that means if del T tends to 0, then we can write limit del T tends to 0 del P by del T, which is nothing but dP by dt, which represents rate of change of momentum. So according to the second law, or according to the Newton's second law, according to Newton's second law, this rate of change of momentum is directly proportional to the force applied. That means we can say F is directly proportional to this del P by del T, right? And if these two are proportional, then we can write F is equal to, here we need a constant of proportionality K, okay, time derivative of P, where K is a constant of proportionality. Constant of proportionality, and its value is 1 in SI unit, right? In SI system its value is 1. So we can write F is equal to dP by dt. And momentum, and we know momentum is equal to, momentum P is equal to mass into velocity, right? Here we're going to write, since momentum is equal to mass into velocity, so here you see F is equal to, so mass is constant, taken out of the derivative, then del V by del T. So rate of change of velocity is nothing but acceleration. So from here we get F is equal to m dV by dt is acceleration. It is nothing but acceleration A, right? So this is the second law of motion, right? Here you see, let me rearrange these things, just give me a second. Okay, now here you see, okay, give me 1 second. Just so sorry. Suppose this is force F, okay, and okay, F is equal to this. So here we're gonna write, since acceleration A is equal to dv by dt, right? Dv by dt, and proof. That's how we can prove it, right? So now we need to write important points about the second law, right? First, let me clean this slide, then I'm going to write the important points about the second law. So important points about the second law of motion, right? Now you see, it gives the definition of force, right? And it is the real law. This is the real law of motion. Why? Because both the first and the second law of motion are contained in the second law. Right? And law of conservation of momentum, linear momentum can be proved using second law of motion. Okay, these are the important points. So now let's move on to next. Our next question is, a pebble of mass 0.5 kg, pebble means you can say stone, okay, is thrown vertically upward. Give the direction and magnitude of net force acting on the pebble during its upward motion, during its downward motion. Now you see, doesn't matter during in upward or downward motion, the acceleration due to gravity is this, okay. So magnitude of the force F is equal to mass into acceleration. Mass is 0.05. We need magnitude, so I'm not considering the direction for the time being, into g. G is here A is equal to g, that is equal to 10 meter per second square. So here it is 10 meter per second square. So this is Newton here, okay, as it is force. So if we multiply this, we're gonna get 0.5 Newton here, okay. So this is the magnitude of the force. Magnitude of the force is this, okay, during upward and downward motion. The direction of this force, now you see, once you have thrown the stone upward in upward direction, as gravitational force is the only force if you neglect the air resistance, okay, gravitational force is the only force which is acting downward. Okay, so in both cases, when it is going upward and downward, in both cases the direction of the force is downward. Okay, so this is the magnitude of the force, and direction of the force during both its upward and downward motion is vertically downward. Right, is vertically downward. Okay, as only the force acting on this is gravitational, only force is gravitational force, and we know always that always gravitational force act in the downward direction, right? So hope you have understood this. Now what is the next question? A batsman hits back a ball of 0.15 kg straight in the direction of bowler without changing its initial speed of 12 meter per second. Determine the impulse. Impulse means here you see impulse is given by change in momentum. So let me clean this first to solve this problem. Okay, so now let me solve the next question. So here these two questions were asked in 2024. So now you see initial speed is 12 meter per second. When it is hit back by the batsman, its direction will be changed. Okay, so minus 12 meter per second, that is the final velocity, and change in momentum is final momentum minus initial momentum. Here final momentum is m into v, initial momentum is m into u, and we know that impulse is equal to change in momentum, right? Impulse is equal to change in momentum. So mass is here, what is the mass given here? 0.15 kg. So 0.15, you can take the m common, right? Let me take the m common, v minus u. So 0.15 into v is minus 12, u is 12, so v minus u. So that's going to be 0.15 into 10 to the power, into minus 24. And if you multiply this 2, then what you're going to have? So that's going to be equal to 0.36. That's what we're going to have, right? Just give me a second. Not 0. So here it's supposed to be 3.6. Okay, 3.6. This is change in momentum, kg meter per second, or you can say Newton second as well. Okay, so this is the impulse, right? So now let me solve the next question. So here you see a body, this was also asked in 2024, right? So here you see a body of mass 5 kg. We have a body of mass 5 kg. Okay, body of mass 5 kg, and acted upon by two perpendicular forces. Okay, one is 8 Newton, another is 6 Newton. This is 6 Newton, this is 8 Newton. Give the magnitude and direction of the acceleration of the body. Okay, first let us find the resultant force. Okay, let me take this force is suppose this force is F1 and this force is F2, right? Angle between them is 90 degree here. So resultant force, the resultant force is, we know how to find the resultant of two vectors. that's going to be equal to root over f1 square plus f2 square plus 2f1 into 2f2 cos 90 degree, and we know cos 90 is 0, so that's why here we're going to have f1 square plus f2 square, that means 8 square plus 6 square, that's going to be equal to 64 plus 36, and here it is equal to root over 100, that means 10 Newton. So this is the resultant force, so let me write net force. So now let's find the acceleration. We know that here mass is given, mass is 5 kg, okay, and we know according to second law of motion, F is equal to ma, so this net force is equal to mass into acceleration. So mass is here 5 kg, so let me put here 5 kg into a, that is acceleration 10 Newton here, 5 kg. So acceleration will be equal to 10 by 5 meter per second square, that's going to be 2 meter per second square. So now let me find the direction. Okay, so direction of the acceleration, direction of this acceleration will be along this force F net, that means the resultant force. Okay, this resultant force, and let me find the angle, let me find the direction. Direction will be given by the angle between F net and F1, or you can give it by the angle between F2 and F net. Okay, so let me take a new page here. So we know that suppose if two vectors A and B, okay, so A and B, this is A vector and B vector, okay, and suppose this is the resultant of these two vectors, and this resultant makes alpha with vector A, angle alpha with vector A, then we know that tan alpha is equal to b sin theta by A plus b cos theta. I hope you know these things. You have if you have studied vector addition, parallelogram law of vector addition. So let us apply this. Okay, so if this angle between F net and F1 force is suppose alpha, in that case here we're going to replace this A by F1, okay, and we're going to replace this B by F2. Then what we're going to have, then you see, let me write here, just give me 1 second. So in that case let me use this, so B will be replaced by F2 and A will be replaced by F1 here, so B is replaced by F2. Okay, now you see what is the theta here. Theta is 90 degree. Okay, theta is the angle between the two vectors, that means F1 and F2. Okay, so here theta is 90 degree, here theta is 90 degree, and alpha is the angle, just give me 1 second. So here theta is 90 degree, which is the angle between F1 and F2. It is already mentioned in the question, these forces are acting at right angle, right? They are acting at perpendicular to each other. So here it is given, you see, perpendicular forces, right? So that's why that must be 90, and let me take that alpha is equal to angle between resultant force, that is F net, and the F1. Let me consider that way. Okay, so if you give the vector sign here, then you have to write here, if you consider this is x-axis, then you have to write 8 icon. Okay, so that's why I am not giving here this vector sign, right? Hope you have understood this. So now, so F2 is 6 Newton, so 6 sin 90 by F1 is 8 plus F2 is 6 cos 90, right? Cos 90 is 0, so that's why this term gonna be equal to 0. Okay, so now what we have, 6 into sin 90 is 1, so 6 into 1 divided by 8, so 3 4 let us cancel it by 2. So we have got 3 by 4. Therefore alpha will be equal to tan inverse of 3 by 4 with F1, with the force F1. So this is the direction of acceleration, right? So what we have to write, so this is the magnitude of acceleration, okay? So acceleration is directed, or you can write this way, acceleration is in the direction that makes tan inverse 3 by 4 with the force F1, right, which is equal to 8 Newton. Hope you have understood this. Our next question is, a projectile has an initial velocity v0. The initial velocity of the projectile is v0 and projected in a direction which makes an angle theta naught with the horizontal. Okay, so here v0 is the initial velocity of the projectile and theta naught is the angle of projection, okay, with the horizontal. Now you see, as only 2 marks is given for the first part, there is one more part here, 2 plus 1 marks is given, 2 plus 1. What is the range in case of vertical projection? Okay, first let me answer this part, first part. Okay, so this is a projectile motion. Okay, so it's thrown with velocity v0, initial velocity v0. Okay, now you see, the along x-axis, this is the x-axis, then the x component of v0 will be v0 cos theta, right? v0 cos theta. If this angle is it is theta not given in the question, so we're going to use theta naught. Okay, it is theta naught, right? And here you see, if capital T is the, let capital T is the total time of flight, total time of flight. So here time taken to reach this point is capital T. Suppose we know that total time of flight is given by T is equal to 2 v0 sine theta naught by z. Okay, this is the expression for total time of flight. Okay, we know these things. Now you see here, let me copy this and let me go to a new slide, okay, so that I can explain properly. So here you see, here we're gonna assume this is known to us, because if we derive this total time of flight also, that's gonna be very long. Only 2 marks is given, so it will be taken as known quantity. Okay, right? Hope you have understood this. So now you see, here we're gonna write, we know this, we know, right? So this is x-axis, right? So along x-axis, suppose this is x is equal to r here, this is the range, this is the range, right? We know that displacement along x-axis will be given by velocity, x component of initial velocity, right, t plus half x component of the acceleration into t square. This is nothing but s is equal to ut plus half at square. That formula is used here. Okay, so hope you have understood this. So now here you see, we know that in this projectile that acceleration along this along x-axis is 0. So here ax is equal to 0, because acceleration is only acceleration due to gravity, that is z. So ay, here ay is minus z, right? So we don't need this for the timing. So that's why this term gonna be equal to 0. So we end up getting x is equal to v naught x. So which gives the v naught x means the, you know, this is the v naught x. V naught x is the x component of v naught, right? So that is v naught cos theta naught, right? And into t. Okay, so when x is equal to becomes r, then small t is equal to capital T, which is total time of flight, right? So we're going to use this results in this equation. Okay, so this is equation number 1. So therefore from 1 if we use these values, okay, then what we're going to have, this is going to imply r is equal to v naught x, means we're going to replace it by v naught cos theta naught, into small t is replaced by capital T, which is capital T means the total time of flight. So r is equal to v naught cos theta naught. So now capital T will be replaced by this, okay, so 2 v naught sin theta naught divided by z, right? Hope you have understood this. So here you see v naught is square, v naught into v naught, that's become v naught is square. So let me write this properly, v naught, okay, then 2 sin theta naught cos theta naught divided by z. So we have a formula in trigonometry, 2 sin theta cos theta is nothing but sin twice theta. So 2 sin theta naught cos theta naught gonna be sin 2 theta naught. So let me use that here. So if we use that, what we're gonna have, v naught square is equal to sin 2 theta naught by z. So this is what we need, right? So this is the required expression that we have shown here. Okay, so hope you have understood this. Now what is the next part of the question here? What is the range in case of vertical projectile? Vertical projectile means it is thrown vertically upward, right? For in case of vertical projectile, sorry, let me write it properly. For vertical projectile, this angle theta naught will be equal to 90 degree, because it must be thrown vertically upward. So that theta naught must be 90 degree, okay, right? If it is 90 degree, here if you put 90 degree, then, you know, if you throw something vertically upward, then definitely it will fall down at the same position on this x-axis. So that's why the horizontal range must be 0, right? Suppose this is a stone and it is thrown from this position on this x-axis, okay, then it is thrown vertically upward, again it will fall down and it will reach the same position. So that's why displacement along x-axis is 0. So therefore range will be equal to, and or if you put here 90, theta naught is 90, then you're gonna get r is equal to v naught square sin 2 into 90 is 180, sin 180 is 0 divided by g. So it's going to be equal to, next question is, a particle is in uniform circular motion, right? So we have a particle in uniform circular motion. This is the particle, suppose this is in uniform circular motion. So what is the angle between the acceleration and velocity? You know, during circular motion, acceleration of this particle is towards the center, which is called centripetal acceleration, and velocity is along this tangent drawn at this point. Okay, suppose at an instant, this is the position of the particle, it is moving with constant speed, right? So at this position, if you draw the tangent, that will be the direction of the velocity. So angle between the direction of the acceleration, that's going to be angle between the direction of acceleration and velocity is 90 degree. Okay, that's going to be 90 degree. Now we need to derive an expression for the acceleration. First, okay, let me take a new slide. And let me tell you one more thing, this question is already done earlier, okay, it is a repeated question. So now let me derive this expression for the acceleration. So suppose this is the circular path and the particle is moving, this is the particle. So the particle, suppose let us consider this particle is now at A, and after a time interval del t it will reach the point B, okay, and this is the center O here, and the position vector of the particle when it is at A is suppose vector r, and position vector of the particle when it is at B it is suppose r dash. Let me write this is r dash, okay. Then here is the displacement vector, okay, this is the displacement vector, let it be del r, right, let it be del r, okay. Now velocity at this point A, which is along the tangent, is suppose v, and velocity when it is at the point B is suppose v dash. Let me take this is v dash, okay. So now first let me write what I have considered here. Now let us consider a particle in uniform circular motion with constant speed v along a circular path of radius r and center O, okay, and let del t be the time interval. Just give me a sec, let me write. It covers a distance equal to the length of the arc, AB, this arc, okay, length of this arc AB from A to B, right. So length of the arc AB in time interval del t, right, del t. Now here let us consider r1 is the position vector of A relative to center O, and r2, sorry, not r1, here it's supposed to be r, and this is r dash, okay. So we have considered the position vector r and r dash, right. So r is the position vector of A relative to O, and r dash is the position vector of point B relative to the center O, okay. So this displacement r del r dash will be given by final position minus initial position, right, final minus initial, okay. Now you see, and let us consider this angle AOB is equal to suppose del theta, okay. Now you see magnitude of this r vector and r dash vector both must be equal to r, which is radius of the vector, radius of the circle, because length of these two equal to the radius of this circular path, and they are different vectors because of their directions, okay. And as it is moving with constant speed v, so this instantaneous velocity at B and A, this V and V dash, their magnitude of V and V dash, that must be also V, right. So now let me go to the next slide, okay. So here is the diagram. Now here you see, first let us take triangle OAB, Okay, so here you see this is OAB, the OAOB, OAB, and this is R1 vector, sorry, R vector, and the length of this OA will be equal to the magnitude of R vector, right? And length of OB will be equal to the magnitude of R dash vector, right? And this, if you join this, it's gonna give you change in position. So here displacement, magnitude of this displacement vector del R. Okay, now let me consider this angle is theta. We have already considered that this angle is theta. Now you see, so the instantaneous velocity direction of V and V dash. Okay, so these are in the these are along the tangent at this point. Okay, the instantaneous velocity at A is along the tangent at this point A, and we know that radius drawn through the point of contact of a tangent to a circle is perpendicular to the tangent, right? So similarly, here you see this this tangent at A must be perpendicular to OA, and similarly tangent at B must be perpendicular to OB, right? So then what we can say, that if you see, suppose you have two lines, this one and this one, okay, and angle between them is suppose del theta, or let me take 30 degree. Okay, so if you draw perpendicular on this line and this line as well, then angle between these two perpendiculars will be also 30 degree, right? Remember that. So now you see, we know we can move a vector, without changing the direction. We can move it anywhere, right? Which is called parallel shifting, right? So if we bring this V vector here, okay, and like this, just give me a second. Okay, if we bring this V vector here and V dash vector as well here, we will get another triangle, right? Let me take this is O dash, A dash, B dash, and this vector will give you change in velocity del V, right? And length of the sides of this triangle will represent the magnitude of this vector V dash vector, magnitude of V dash vector. Okay, magnitude of V vector, it will, the length of these sides, you know, of this triangle will represent magnitude of this vectors V dash. Okay, just give me a second. So length of O dash B dash will represent the magnitude of V dash vector, and magnitude of V vector will be represented by the side O dash A dash, right? O dash A dash, and the magnitude of this vector del V vector will be represented by A dash B dash. Okay, and here del V magnitude del V vector is change in velocity, that is final velocity minus initial velocity, right? So here you see this angle must be also del theta, as I have already explained. Why del theta? Because the direction of V, instantaneous velocity at A, is along the tangent at A, and if this is the point of contact, and radius through the point of contact is perpendicular to this tangent. Similarly, velocity at B, instantaneous velocity at B, it must be also along the tangent at B, and if you draw the radius at B, that must be perpendicular to the tangent at B. So as I have already told you, that if you have two lines and you have angle between these two lines is suppose del theta, then if you draw perpendicular on the two lines, then angle between these two lines also will be equal to the angle between the angle between the perpendiculars will be also equal to the angle between the two lines, right? So now you see acceleration. We know that acceleration is given by the rate of change of velocity. So del v is the change in velocity divided by del t in time, del t, as I have already mentioned here, I think. Okay, so it covers a distance equal to the length of the arc a and b in time interval del t. So here you see, so at a velocity is v, at b velocity is v dash, so velocity changes from v to v dash in time interval del t. So that's why acceleration, this is actually average acceleration. Average acceleration is this is average acceleration. Average acceleration of the particle of the particle as this. Okay, now let me write instantaneous acceleration. Instantaneous, just give me a second. And the instantaneous acceleration will be given by, this was average acceleration actually, let me write that way. Instantaneous acceleration is given by a vector limit del t tends to 0 del v by del t, right, when the time interval is very small, right? So hope you have understood this. So now you see this acceleration is directed towards the center, so it is called centripetal acceleration. Right, so this is called centripetal acceleration. So we're going to write it as ASC. Okay, so now you see from these two triangle AOB and A dash O dash B dash, what we have got here, you see, now in these two triangles we know that OA is equal to OB is equal to R, we know that, and we also know that O dash A dash is equal to O dash B dash is equal to V. V is the speed, and which will be equal to the magnitude of this V dash and V. If magnitudes are equal, then the vector representing the sides of the triangles representing these vectors which are equal in magnitude are also equal in length. These two sides which represents these two vectors whose magnitudes are equal, so length of these two sides must be equal, right? And their magnitude is equal to V. That must be equal to the constant speed. Okay, here this velocity, these two velocities are different because of their direction, but their magnitudes are same. Okay, so that is V. So from these two relations, what we get, if you divide this above equation by this equation, what you're gonna have, OA by O dash A dash is equal to OB by O dash B dash is equal to R by V. That's what you're gonna have. So now OA, OB both equal to magnitude of R vector, right? That is R, and Similarly, these two are equal to magnitude of v and v dash, so that is v. Okay, so now you see this implies, before that let me tell you one more thing. And as I have already told you, these two angles are equal, right? So since angle AOB is equal to A dash O dash B dash, these two angles are equal, that is del theta. So here you see we have got that these two triangles are similar according to side angle side property. Triangle AOB similar to triangle A dash, triangle A dash O dash B dash according to side angle side property. Here you can see these two are the ratios of these two sides, this one and this one, and OB and O dash B dash. Okay, and we have got the angle between these two pair of sides are equal. Okay, hope you have understood this. Therefore, according to side angle side, these two triangles are similar. If these two triangles are similar, then we can say, okay, just pause the video and note this. I'm gonna clean this diagram. Okay, so let me clean this. So now here you see, okay, let me write here remaining part of this solution. Okay, so this remaining steps will be continued here. Okay, here you can see. Now you see, since we have got these two triangles are similar, therefore we can say this ratios of the sides. So here we have got the ratios of two pair of corresponding sides of the two triangles. So as these two are similar, so we will get these two ratios are also equal to this ratio as well, this ratio, that is AB by A dash B dash. Okay, so now you see what we can write, R by B is equal to A dash B dash and AB. AB is the change in, AB is the magnitude of the displacement vector del R, right? And A dash B dash is the change in velocity del V, right? So magnitude of del V vector. So from here what we can do, let me write here, del R vector is equal to R by V into del V vector. Okay, so now let me copy this step and let me go to the next slide. So here is the last step we have got. Now let us divide both sides. Let us divide both sides by del t. Right. Let us divide both sides by del t. And let us take limit. Taking limit on both sides. Limit del t tends to 0. Limit del t tends to 0. So this part is constant, so it can be taken outside of the limit, right? So limit del t tends to 0. Okay, let me write this here. This is what we have got. Now let me go back to the previous slide. Now you see, from this equation number 1, we have got that centripetal acceleration is this. So now you see, if you take the magnitude only, AC is equal to, then we're going to write limit del t tends to 0. As we are taking magnitude, so we're going to take mod of del V vector by del t, which is nothing but this part. Here you see, this is the centripetal acceleration, right? If you compare this, so we can replace this by AC. Okay, so here we're going to write R by V into AC. Okay, using equation number 1. So here I have given, this is equation number 1. Okay, this is equation number 1. So now, so here you see, this is nothing but velocity, right? This is nothing but velocity. So as we are taking mod here, so we're going to write the magnitude of velocity, that is v. V is the constant speed. Okay, and that speed will be equal to the instantaneous velocity, right? this instantaneous velocity, right? So here you see AC will be equal to V into V, that's going to be V square by R. So this is the expression for centripetal acceleration. So this is the required expression. So this is the required expression. Right. So thank you for watching. See you in the next video. Bye bye.